Welcome back to our series on getting started with .NET package management using NuGet. Today, I'm going to be talking a little bit about some best practices when using NuGet. Essentially, best practices on both sides as the package consumer and the package author really all boils down to what's included in the package metadata. So I'll start off by talking a little bit about how to write some good package metadata as a package author, and then in turn, I'll use that similar information to talk a little bit about what you should look for in the package metadata as a package consumer. So let's get started by talking about package authoring best practices. Semantic versioning. So something a little bit more specific to package authoring is semantic versioning. It's a versioning scheme for software that aims to provide a clear and meaningful way of communicating changes in your code. It's not just about incrementing numbers, it's about communicating the impact of those changes. So how does it work? It's structured as major.minor.patch. The major version is incremented for backwards incompatible changes, or any changes to your package that if a user were to download it, then it might result in a breaking change for someone using the package. A minor version increases for backwards compatible, but new functionality. So say you're adding a new feature, but someone downloading the package wouldn't have any issues if they were currently using it. That's when you would do a minor increment. The patch version is bumped for basically just bug fixes. So any small change, maybe not a new feature, but fixing something in your package, you could use a patch. In addition, pre-release versions or any updates to your package that aren't yet stable can be appended for an even finer grained control using the suffix option. Now, why is this convention important for NuGet package authors? First, it provides clarity. Semantic versioning is a common language for you and your users. It tells them exactly what they can expect when they update your package. Additionally, users are more likely to upgrade to the latest version if they trust that it won't break their code. This is a good way that you can use to communicate to them whether or not it will do that, and it's essential for maintaining a healthy user base. It's not just a set of rules, it's a tool that fosters trust and an effective communication method in the world of software development, especially for NuGet package authors. By following this scheme, you're not only creating better software, but you're building stronger relationships with your users. So let's talk a little bit about some other metadata you can include to foster trust. First, we have the author field. This should use your organization's pretty name and not just an abbreviation. For example, if my NuGet package username is JDoe, then using Jane Doe for the author field might help users recognize me as an author. If my organization's NuGet.org username is Contoso Toolkit, then using something more like Contoso Corporation may be more recognizable and inspire more consumer trust. Next, the description. Package descriptions are one of the most prominent fields surfaced in NuGet search and will likely be the first thing potential customers look at to determine if your package is right for them. Make sure that when publishing a package, you include a description that describes what the package does in a way that is succinct enough that a user can understand it quickly. You can include a longer and more detailed explanation of how to use your package in the Readme file, which I'll talk a little bit more about in a minute. Next, the package URL. Package authors should include a link to an associated project, repository, or company website. Your project site should have everything that your users need to know about your package, and this will likely be where users look for documentation, so make sure to utilize metadata tags to thoroughly document all relevant information. Additionally, package authors can set up source link to automatically add source control metadata to their NuGet package and make your library even easier to debug. Source link automatically adds the repository URL and repository type to package metadata. You can find more information about how to do this in NuGet documentation linked below. Next, an icon. You should consider including an icon with your package to help visually differentiate it. It's relatively small, but it's something that can really improve perception of package quality. Icons can be specific to individual packages, or it could be a brand logo or the company logo of what you're working for. Might seem small, but it really makes an impact on trust, and consumers might think that you put a lot of time and effort into it. Next, licensing. A project without a license defaults to exclusive copyright, meaning that you've essentially not granted anyone permission to use your project. Depending on your use case, you can decide which package license might be right for you and include this in your package metadata. Next is release notes. Each time you update your package, whether it be a minor version update or just a bug fix or a major release, be sure to add release notes to describe what changes were made to provide full transparency with your users. This will help build trust. And lastly, a README. Probably one of the most important pieces of metadata that you can include in your project is a high-quality README Markdown file. Let's talk a little bit more about this in depth. But first, let's address the why. Why should a NuGet package author bother with a README file? First, your README file provides a first impression of your package. Your README is often the first thing users see, and your package's front door. Make it inviting, informative, and user-friendly to leave a positive first impression. Second, a README file serves as a documentation hub. It offers essential information like how to use your package, its purpose, and its features, helping users quickly understand its value. Additionally, if issues arise, a well-structured README can assist users in solving problems independently, saving you time on support requests. And lastly, a polished README demonstrates your commitment to quality. It tells users that you care about their experience and helps build trust in your package. Detailed here is some really specific information that you should include in a high-quality README. Next, another way that package authors can communicate trust is through applying for prefix reservation. This is a way that a package owner can reserve and protect their identity, and also communicate trust to their users. Each request is individually reviewed by the NuGet team. To learn more about the process and to request prefix reservation for your package, be sure to check out the link in the description. So now that we have a basic understanding of best practices that package authors should follow to build a high-quality package which conveys trust to users, let's think about it from the perspective of the package consumer. That I am a developer who is looking to download a NuGet package to help me with implementing an integration with OpenAI software. On NuGet.org, I can type OpenAI and see what results I get. So now I see around 200 different results for packages related to OpenAI, which can be overwhelming. But NuGet has a few features in place that make it easy to determine package quality at a glance. Without even clicking into a specific package for more details, we can see a few pieces of information about a package returned right in the search results. First is the author. We can see the name of the author, and we can click on their name to get some more specific information about their NuGet activity, such as what other packages they might have authored and how many downloads they have across all packages. This is especially important in the case of one search result on this list, which is authored by Microsoft. This indicates a very high standard of trust and quality that I would receive with this specific package. Next, we have total downloads. A high number of total downloads on a package can indicate that many people have used and potentially recommended this package to other people before, which might indicate trust. However, some packages have just been around longer than others, so it's important that we don't use download count as a sole measure of quality. Next, we can see the last update date. This gives an idea of how recently someone has paid attention to this package and updated it. If a package has gone a really long time without having been updated, it might not be relevant anymore. Next, we can see the version number, which also gives an indication of how many times a package has been updated and if it's being monitored and updated periodically. Last, we can see a little snippet of the description, which provides a glimpse into what the package does and if it might be able to solve my specific use case. Lastly, I can see if a specific package has a prefix reserved, which indicates that someone has cared enough about this package to reserve its prefix. Now, this package by Microsoft, azure.ai.openai, looks pretty credible to me. It has a relatively high download count, its prefix is reserved, and Microsoft is listed as an author. And based on this description, it looks like it might do what I need it to do. So let's take a little bit of a closer look. First, I'll start by looking at the README file. Wow, this README looks like it has a lot of good information about how to use the package and some examples on implementing it in my code, which will make it really easy for me to use this package. Next, I can take a look at the compatible frameworks to see if the framework that I'm using is compatible with this package. Next, we can take a look at the dependencies that this package has. This package has a really small number of dependencies, only 2. If a package has a lot of dependencies, things can get really complicated with maintenance and updates, so a small number of dependencies is really good when determining or when evaluating a package. It reduces the risk of a vulnerability. Next, we can take a look at what other packages are using this specific package. We can see that this package is used by quite a few packages with a lot of downloads and notable GitHub repositories with a lot of stars. This further indicates trust in that if these notable and popular packages depend on this package, then it's probably of high enough quality for me to use it as well. And lastly, we can take a look at some versions. So we can see some information about versions that this package has released and how frequently it's been updated. This package has been updated a few times in the last year, and it seems to have updates frequently, which means someone's actively monitoring this package for bugs and improving upon its functionality and quality. With all of this information taken into consideration, I think that this package seems pretty trustworthy, and I want to take it on as a dependency. It's important to remember that we need to look at a package holistically. Not just any of these qualities of a package indicates trust. For example, if a package has a high-quality Readme or has a lot of downloads, or just one of the qualities that I mentioned, that doesn't necessarily mean that it's trustworthy. But looking at all of these pieces together, if a package has many or all of these qualities, then that's when I can really understand if it's a trustworthy package. In this video, we covered some best practices about package authoring and what to include in metadata to create a high-quality package. And in turn, we use that same information to look at what a package consumer should look for when they're determining what package they want to download. In the last video in this series, I will talk a little bit about package security and how you can keep your information secure when you're using NuGet. See you next time.